Welcome guys in today's lecture of digital logic circuit design implementation using Multisim. In today's lecture we are going to implement XNOR gate using multiplexer. So in XNOR gate, if all inputs are high, if all inputs are 0, if all inputs are 1, output is always going to be 1. And if odd number of inputs are 1, output is going to be 0. So this is exactly opposite of XOR gate. We have taken one input as select line. I have taken A as select line and B is passed to second input and B is passed as complemented part input in first input. So let's rename our select line to A, and it will help just to understand with our logic. By renaming this thing we can map these things. So B is passed to the second input and B in complemented form is passed to the first input. Let me place this NOT gate here. Okay, so now this is our XNOR logic implementation using multiplexer. So when A is 0, output will be B bar, and it's nothing but simple logic operations of NOT gate and AND gate. See here, it is 0, after NOT gate it will become 1. Again A is 0, after NOT gate it will become 1. So AND gate is having two ones at its input. AND gate output will be 1. And you know that if in OR gate any input is 1, then output is going to be 1. So this is basic operation of AND NOT OR gate. But in our output it will appear that if both inputs are 0, output is going to be 1, and that is the basic operation of XNOR logic. Similarly, if A is 1, then the second input will be selected. So here it is 0, output will be 0. If it becomes 1, then output will become 1. So both case 1 1, output is high. And this is nothing but the logic implementation of XNOR gate using 2x1 multiplexer.